In this video, we're going to be talking about choosing what to use, thinking about all of the methods that we've used so far this year, but mainly focusing on the ones from this unit when we're dealing with right triangles. If you think about all of the things that we have done this year dealing with triangles, we've talked about congruent triangles, similar triangles, isosceles triangles, equilateral triangles. Now we're getting into right triangles. We got a lot of triangles that we've been dealing with. So one of the biggest issues I've seen so far is students having to choose what to use and having a hard time with knowing, do I use this method or that method? So what I'm going to be focusing on here is determining which of our methods we're going to use for solving right triangles. Do we use the trig ratios? That would be the sine, cosine, and tangent. Do we use the inverses of the trig ratios, which are the sine -1, cosine -1, tangent -1 in the calculator? Do we use Pythagorean theorem, a squared plus b squared equals c squared, or do we use some other method? The main thing to know about using some other method is that if you're given non-right triangles, you can't use the trig ratios, the inverses, or Pythagorean theorem. Usually, if we do have a right triangle, we're using some other method if we're given angles only, and we're looking for another angle, because that would be using the fact that angles add up to be 180 degrees. So let's look at our three major ones from this unit and talk about what we're given and what we're solving for and how to make our choices. So if you are given at least one side and one angle, and you're looking for at least one side, the only way that you could solve it is to use the trig ratios, sine, cosine, or tangent. So you'll see I got an example at the bottom. That's very similar to the ones that you've been doing and that we've been practicing. We also have the inverses of the trig ratios. In order to use the inverse, first of all, you must be looking for an angle, okay? If it's not an angle, you can't use the inverses. But in order to use it, you must be given at least two sides of the right triangle. If you're not given two sides, or you can't figure out one of the sides, then you can't use a ratio, or you can't use an inverse of a trig ratio. Pythagorean theorem, you must be given two sides, just like when we were using the inverses of the trig ratios, but you would be solving for a side instead of solving for a triangle. So what I think you need to do right this second is get a piece of paper. I want you to copy down the givens and the solving fors and the example for each of these choices. So pause the video and copy these down now. So let's look at some examples of how to make the choices. So this says, what do I use? Do I use trig? Do I use trig inverses? Do I use Pythagorean theorem? Or do I have to do something different? So let's look at number 1 where it says solve for D. So we're going to go through and look at each of our given pieces of information. So for this one, we know that we are given that it's a right triangle. All right, so we're given one side, one of the acute angles, I'm just going to say one angle for that, and we are looking for a side. So if you look at your list, the only way that we can solve for this is to use our regular trig. We can't use the inverses because we're not looking for an angle measure. We can't use Pythagorean theorem because we're not given two sides, and there's not any other method that we can use to solve this except for our trig ratios. Okay, for number 2, let's look at what we're given. This is a right triangle. Okay, so I always try to look at that first. If it's a right triangle, I know what my options are for the most part. Alright, I'm given two side lengths. I'm not given any angles except the right angle, and all that told me was that it was a right triangle, so I'm going to say no angles. And I'm looking for a side. Okay, so for the trig inverses, I would have to be looking for an angle, so it can't be those. To use trig, I would have to be given at least one angle, one of the acute angles, and one side. I can't use that. For Pythagorean theorem, that's given two sides, looking for one side. I got it. I can use that. So for this one, we would use Pythagorean theorem. All right, for number 3, it says solve for theta. Okay, so I'm looking and I'm given that it's a right triangle. I got two sides. I got one angle, other than the right angle, of course. So I can't use trig because I'm not looking for a side. I can't use Pythagorean theorem because I'm not looking for a side. To use trig inverses, I have to have two given sides at least and one angle, and there's no other way to solve it except for trig inverses. So that's what I would have to use, the inverses of our ratios. Number 4 says to solve for x. Well, this isn't a right triangle, so that means I can't use trig inverses, or Pythagorean theorem. So the only way to solve this is to add 70 and 50 and subtract from 180. Because when you're given two angles and looking for an angle, that's the easiest way to do it, the 180 degrees. All right, let's look at a couple more. Solve for angle E. Okay, so I'm given that this is a right triangle. I'm given three sides. I'm not given any other angles, so no angles. Looking for an angle. Okay, so I can't use Pythagorean theorem because I've got all three of my sides. I can't use my trig inverses because I have to be given at least one side and one angle. So I don't know if did I say trig or trig inverses? I meant you can't use trig depending on what I said. That means that we must use our trig inverses because we were given at least two sides. In this case, we were actually given three. So if we're looking for one of our acute angles, we use the trig inverses. And the last one we're going to look at, it says solve for angle K. We are given that this is a right triangle. We are given one angle besides the 90-degree angle, and no sides, and we are looking for an angle. Alright, well, we can't use trig or Pythagorean theorem because those would have me looking for a side. To use the trig inverses, I'd have to have at least two sides. I don't have that, so I must have to use some other method. And in this case, again, I would use the fact that these have to add up to be 180 degrees, or the fact that angle I and angle K are complementary and add up to 90, which would mean that angle K is 45 degrees. So I would have to use 180 degrees. So I hope that this helped you with some of the choices that you have for the trig ratios and inverses and Pythagorean theorem. So you're having some questions at the end of the video. And about now you should be done.